Dielectric materials are non-conductive materials applied over conductors that prevent breakdown from shorts, arcing, and discharge. These materials isolate neighboring conductors from one another in devices like high-voltage transformers and electric vehicles to small motors and household appliances. In this video, we'll explain what dielectric materials are, how they work, and why they're an important material in the electronics that power our daily lives. Let's start with dielectrics. These are materials that block the flow of electrical current, but still allow an electromagnetic field to pass through. This is where they get their name from. Dia, Greek for passing through, and electric, referring to electric fields. Dielectric strength refers to the maximum electric field a material can withstand before it breaks down and begins to conduct electricity. It's measured in volts per unit of thickness, so thicker materials resist higher voltages. The voltage at which a failure of the material occurs is called the breakdown voltage. This machine is called a high-pot tester, and it measures the breakdown voltage of materials. A sample is placed between electrodes and the voltage is raised at a constant rate. Charge builds up on the sample surface as it resists passing current until there is enough energy to break down the material. At this point, the cell is an open circuit and current passes to the grounding electrode, triggering the machine to stop. The voltage where this breakdown occurs is recorded, and that voltage divided by the sample thickness is converted to the dielectric strength. A dielectric material, therefore, is a specialized insulating layer designed to block electrical current and provides additional protection against environmental factors like moisture, dust, and salt water. These materials are everywhere, hidden inside the devices we use every day. Take this laptop charger, for example. It's common to find dielectric materials wrapped around internal components such as transformers. Or this old drill battery. See those conductive metal pieces? They're called bus bars, and they're protected by a dielectric material to prevent short circuits. For simple shapes like bus bars, materials such as Kapton or PET tape work well. But when it comes to more complex geometries, like the windings of an electric motor, these tapes are much harder to apply. One alternative is epoxy powder coating. While it can conform to irregular shapes, it requires additional equipment such as a spray system and an oven for curing. It also has a major drawback. Epoxy powder is brittle and prone to cracking, which makes it less than ideal for applications exposed to mechanical shock, such as power tools or electric vehicles. Insulation coatings like MG's 4226A and 4228A provide a superior solution. Like epoxy powder, they easily conform to complex geometries, but without the need for specialized equipment. They can be brushed on or applied by dipping, and they cure at room temperature. Most importantly, these coatings remain flexible, resisting physical shocks while maintaining excellent dielectric strength. Both of MG's insulation coatings are classified as CTI Material Group 1, indicating outstanding resistance to surface electrical breakdown. This places them among the most durable and reliable options for demanding, high-performance applications. If you need the ultimate solution for PCB protection, potting compounds stand in a class of their own. These incredibly tough materials can be selectively applied to critical areas of a circuit board for localized defense or used to completely encapsulate an assembly for maximum durability. Among dielectric materials, potting compounds deliver unmatched performance, combining excellent dielectric strength with outstanding mechanical protection. Beyond electrical insulation, potting compounds fortify assembly housings, fill large voids, and protect components against static discharge, chemical exposure, humidity, and even saltwater corrosion. MG's comprehensive range of potting compounds includes epoxy, silicone, and urethane formulations, each engineered for specific performance advantages. Our lineup features both clear and black versions for protecting intellectual property, as well as UL-rated flame-resistant options. Every MG potting compound is RoHS compliant, ensuring reliability and global compliance. Electrical connections must be protected from water and moisture, especially in outdoor environments. Dielectric grease is a thick, non-conductive gel that forms a protective barrier against water intrusion. Its gel-like consistency allows it to seep into small gaps and crevices, creating an effective seal within connectors. Beyond moisture protection, it also helps preserve rubber boots and O-rings by keeping them soft and flexible over time. Products like MG's 8462 are commonly applied to automotive battery terminals, where they block moisture, prevent corrosion, and ensure reliable electrical contact. Our 8462 dielectric grease is safe to use on rubbers and plastics and will not harden, melt, bleed, dry, freeze, or separate due to temperature fluctuations. From everyday appliances to advanced electric vehicles, dielectric materials play a vital role in keeping our technology safe, reliable, and efficient. By insulating components and protecting them from environmental stress, these materials prevent electrical failures and extend the life of critical systems. Whether it's for a simple motor or a high-voltage EV battery, dielectric materials are essential for powering the technology that we depend on.